We'll go ahead and get started. So hopefully you're hearing about AWP plus Lean plus DfMA. All right, so let's do some introductions here real quick. I think we've got everybody in here. All right, so we're going to have a little bit of our agenda here. We want to make sure that we talk about what we really want to do, and we're going to have a little Slido set of questions for you. And then we're going to talk a little bit about AWP, what we want to frame as the structure of project delivery, a good structure for it. We want to talk about Lean, which is a value-driven proposition-based methodology. So we want to talk about the value that Lean provides. And then from the DfMA, and if you're familiar with DfMA, Design for Manufacturing and Assembly, right, which is going to be part of the future, I think, of all our work efforts, is how do we modularize as much as we can. We're going to reference that as a way to optimize our overall workflows, right, and project outcomes. So we're going to then go into a few case studies, and then we'll open up to some Q&A. All right, fair enough. Okay, so let's go through some quick introductions. My name is Fernando Espana. I'm the president of Constructex. We've been involved with advanced work packaging since 2012, helping shape a lot of the things that you're probably using today. We contributed digital threads to CII and got started getting into data requirements. We contribute a lot of AWP capability work, so to help define what AWP really means and what it means to go do it. And of course, we've been involved with a lot of technologies and supporting AWP. Before that, I come from a Lean background as well. In fact, some of my colleagues here, we worked together many years ago on some very Lean projects. So I have a Lean construction background. I have a background in 3D technologies, and it's that where we started really seeing the value of combining and blending these techniques as part of a project delivery process. So next, let's let Nigel Harper introduce himself.
Hi, I'm Nigel Harper. I'm a civil engineer by training. Worked for 20 years for O'Rourke and Lang and Kia back in the day, and the last 15 or so years been helping people implement Lean tools and techniques on projects across Europe, mainly, to be honest. It's my colleague Peter.
Hi, I'm Pete. Much like Nigel, I'm from the general construction industry. Background in MEP, mechanical, electrical, and public health project delivery, with components of Lang O'Rourke, Crown House Technologies. Touched upon, I'm a newbie to AWP, but touched upon it doing some industrial projects in Australia. For the last 4 years, I've been a Lean construction practitioner with IPD. That's me.
All right. Okay, fantastic. So what we're going to do is open up your Slido. So if you have your devices with you, we're going to ask you some questions.
I'm going to cross our fingers it's going to work.
Yeah. All right.
Work your magic, Steve.
Okay, so.
You need to switch over.
Challenges, is that right?
Yes. Okay, so you should be seeing the top 3 challenges. So if you, or the top, I think we have like 12 on there. So if you could go through that list and pick out 3, what are the top 3 challenges that you find? Doing it differently, really, here on AWP especially.
Oh, spring, Steve.
Oh yeah, it's on extended.
Thank you.
Perfect. Supply chain not aligned, hard to change the mindsets. Procurement methods don't support doing it differently. Commercial. If you're like me, when you thought of this, you had the same issue on all projects. All right, got a few more votes coming in. these are pretty representative. Hard to change the mindset. Supply chain is not aligned. Procurement methods don't support doing it differently. Lack of data. Learning resources doing it differently. Commercial agreements don't support changing. All right, that's good. Let's go to the next one. All right. So what do you perceive as the top 3 challenges facing your projects and programs today? A little different perspective, but now project focused. So pick 3. Maybe the harder 3 to pick. Okay, more productivity and late schedule, shortage of competent labor resource, inadequate planning. Yeah, those seem to be the popular ones. This is a good one. Too much change in design, client requirements. We just heard that from Morley earlier today. Yeah. Nice. Okay, let's, so productivity, planning, and labor seems to be the hot topics of the day. Let's go to the third. All right, what's stopping the journey to net zero? Are we picking 3 on this one? Yeah. So pick 3 again. Yeah, this is all about climate change, focus. So we're getting, technology techniques, industry not aligned. Technology techniques don't exist to move away from our carbon-intensive ways, yes. Lack of data and learning on what net zero is, and how do we get there? All right. Not aligned, and that's what we're going to try to do this weekend, get some alignment, at least within our group. All right, thank you.
So what we're going to try and do is, as we go through the presentations and the case studies, hopefully you can see how some of the stuff that we're going to show you will link to some of those challenges you just threw up there. Not all of it, but some of it.
Yeah. Okay, get back here.
Thanks, Steve.
All right, those are our questions. Okay. So what I'd like to share with you, and I think everybody could recognize this, is when we talk about project delivery, we have to look at people, process, technology, and culture, right? We hear it over and over again, but what does that mean? And they're nice things to say, but when we have to actually go do a project or within our organizations, this is what we deal with, right? So how does advanced work packaging really contribute to that? How does Lean, how does DfMA look at that? If we isolate it, we're not really gonna get where we wanna go. Right? It's very complex issues and situations, no matter which organization you're in, which project you're going to go pursue. It's, all these considerations is a mix. What people issues or opportunities do I have, process, technology, and culture. Culture is probably the main factor, because if we can't get the culture to change, we're gonna have a lot of frustration and slow improvement. So, what we're proposing is that we should be looking at a blend of solutions. And that is our AWP solutions, there are Lean solutions, and there are DfMA solutions available to all of us today, and they're actually rapidly improving as we go. So if we look at AWP, and I mentioned before, AWP brings structure. There's a lot of other benefits, but it's certainly, as from an overall, and we've heard this from the lean community, that there's a structure there that would benefit the lean side of things and also the DfMA side, right? So from lean, we want to look at from a value perspective, again, is if we always look at where is waste, how do we remove that waste? What is value to the customer? What is value to our foreman? What is value to all the other players? And how do we increase that value, through our projects and within our organizations? And then of course, DfMA and Pete's got some exciting stuff about that's happening with around DfMA that contributes to how we rethink our projects. What are those assemblies? What are those optimal assembly? Are we going to be 25% of pre-assemblies and modules? Are we going to be 75%? And what is this mix? And I've seen these studies where simultaneously building in a 3D model can help determine what that optimal mix might be. But we don't really give it too much thought. So if we look at all these together and look at that blend of work, we should end up with some confluence of solutions, right? Pulling from all over and saying, this is what we need to do on this project specifically, versus, in my organization, on a small scalable project all the way up to the mega giga projects, right? We have to look at the entirety of the opportunities of the solutions, because there's not going to be any one solution. If you just go out and say, we're going to dust off the AWP book and just apply it this way, and then most of you that do apply AWP know this for a fact, that it's very, very customized to the project itself. Okay, so let's move on. All right, so we'll talk a little bit about AWP. And none of this is to say, here's what AWP is. You heard the overview this morning. This is about starting to look at the opportunities where we can start mixing things into our AWP world. All right, so you all know that there's books out there that you can go read and become familiar with the textbook stuff. So but we want to advance that. You've all seen this, where the project, life cycle goes through, and we want to take it from a concept all the way through to execution by building discrete packages all the way from project start all the way to handover to operations. Right? We all understand this about AWP. We break down that process into what's really going on in AWP. We can look at how do we want to set up the project? How are we going to deal with our path of construction? How are we going to start aligning with construction, engineering, procurement, fabrication, our material flows, and then we start looking at, okay, that's going to help shape the master project. And of course, here, feasibility studies and CDP readiness reviews and releases, all represent things that happen before construction, pre-construction. Not that we have to have 100% of all that done before we start construction. We want to feed to construction, the things that are ready, right? That's the whole CDP release process, is what is ready in the right chunks, in the right order, that are going to advance the project. So it's not start, 100% everything. It's a continual flow of opportunity to go do work. All right. Same thing on the construction side. As we receive CWPs, there's a readiness setup where we're going to start doing IDP scoping and sequencing, constraint identification, short interval production control, which is something that we don't really do very well, and where Lean can really help us, right, to drive an IDP closeout, and of course now streamlining turnover, test and turnover, and all of a sudden commissioning and startup, right? A lot of it thinking with the end in mind, of course, but this is the construction side. As we get work, we go execute work that's ready. Now, what I've done here is overlaid that with little red flags saying everywhere we can start applying lean project delivery type thing. So you'll see here, there's last planner system, choosing by advantages, big room methodologies, collaboration centers, pool planning, integrated project delivery. We heard about collaborative contracting, right? So this comes out of the lean world. So BIM, target value design, integrated agreements, daily huddles, performance reliability, decision-making processes, tact time planning, DfMA, and ergonomics, right? So all these are things that don't really make their way into our AWP language, but they are available for us to start applying, as you can see here on the pre-construction side, certainly in many ways. And then of course on the construction side, the same opportunities exist. But if we keep looking at the same formulas of things, of advanced work packaging or lean construction, we're going to miss the other opportunities that are available to us through all these different techniques. So what is that blend, that we're going to start applying in advanced work packaging? Another view, and we talk a lot about project management, everybody talks about project management and the opportunity that this is a tool, it is a tool for project management, but it is also an excellent tool for production management. So if we start thinking that 50% of the value is in project management, but we're building things, so how do they get built? It's all about production management. So AWP absolutely contributes in a big way. This is our factory. That's the factory that builds things, right? And if you're in the lean world, right, and if we look at the AWP process, this will be familiar to you. Here's what I should be able to go do. Here's what I can do in the look-ahead process and the IWP release plans, right? Here's what I will do in the short-range commitments, and then I'll go execute. So this is what I do, this is what I'm going to go do, and this is what I did in the IWP closeout. So there's lean concepts built into this, but let's start thinking about how do we actually leverage lean construction and DfMA in this process. So as you know, this is just an influence curve that we're looking at. Hey, early on we have the most opportunity to influence, and of course when we're out here we have the least opportunity. There's a whole bunch of flows and the challenges and opportunities and all the transitions that happen in a continual flow of work in the AWP world, because we're always releasing things, right? And if we look at it from a production perspective, right, we have the goals, the design engineering, detail engineering, fabrication, assembly, and finally we're going to deliver the logistics delivery, and then finally an install. So, we're always recycling the path of construction, the CWPs, EWPs, the PWPs, IWPs, and then finally into the system work packages to get to a turnover, right? So the fact that this machine starts working, we can start looking at how does this apply to advanced work packaging, and we all know this kind of curve. And if we look at it from a production perspective, it's all about workflow, production flow. It's all about information flow, right? So early on, as we get these goals, right, we have a lot of input that comes in as information flows. We have design flows to release things. We have supply and logistic flows to get things out to the field when we need them. And then, of course, the site assembly flows. So if we look at it from a production perspective, right, we can really do a lot of, I would say, optimization in this case, and synchronization. So again, path of construction information flows, requirements, status, approvals, logistics delivery, material management, just loaded. The series of IWPs to complete a CWP, critical milestone, align it to systems, align it to modules. Right? So we can start looking at the flow of work. So when we put our mindsets, and as we go through, we'll have a little discussion about lean and DfMA, keep that in mind. This is a machine. There's a factory. The factory is our projects. And not only do we have to come together with a structure, but we also have to look at how does material and design flow and information flows and the site assembly flows go through this. All right, and overlay that with what our work packages represent. POC, path of construction is great on the information flow. Engineering work packages over here, procurement work packages to make sure the delivery is correct, right? And then of course the CWP, IWP assembly flow on this side. All right, so that was a little bit about where I think AWP fits in. Nigel's going to take us through the lean.
Hi. Okay, so a little quick whistle-stop tour. So we kind of set this presentation up to be how things are different. And what we ended up was kind of like, there's a lot of similarity, isn't there? So let's start at the beginning. Okay, so, come on, build that, never mind, build it like that. Just to give you a little bit of background, real simple stuff. So back in the day, there was craft production, people made one-off things, it was made to order generally, it was highly skilled, it was artisans and all those good guys, yeah? Then Mr. Ford came along and he said, you can have everything you want, as long as it's one of these and it comes in black. So that's the way mass production got into the mindset and actually started to give us products across a much wider range of people. And then kind of post-Second World War, Japan, because of what happened at the end of the Second World War, basically had very little infrastructure, very little money, and they had to set up a different way of working, which Toyota embraced, to say how can we make something without basically any resources, and how can we make things without having to use working capital and cash, but actually give customers what they're looking for. So this whole concept of lean, which is based on the total production system, was brought into being. And this is kind of the idealization of it. Customer product delivered instantly with nothing in stores. That's what the whole lean methodology is all about, but delivering value to the customer. That's the critical piece. So that's kind of the history. Okay, so there's a bunch of stuff involved with lean that people kind of get scared of and turns them off. So there's a bunch of Japanese phraseology, and really, if you break it down to what it actually comes back to, the whole process is about removing waste. It's about how you can look at the way things are done and actually remove waste and actually drive better value for the customer, save money, and get a better product. That's really the essence of it. What happened then back in the 80s is that a couple of guys, James Womack and Dan Jones, went over to Japan at the invitation of the Japanese, going back to that whole sharing knowledge piece, to actually figure out what is it, what is lean, and how can we bring it across into Western manufacturing and make things work. And as Fernando's talked about, they figured out it was a lot about flow. It was about really understanding what the customer's looking for, and they came back with a couple of books they wrote to actually start to influence the way Western manufacturing changed. Okay? And I'm not going to go into the metrics, but back in the 80s, that's how far behind we in the Western world were compared to what the Japanese guys were at. So we figured out we had to do something different. Let's fast forward to construction, because that's where we all work. So construction, lean came into construction in the early 90s. A group of guys, Glenn Ballard, Greg Howell from LCI, Glenn taught me, kind of figured out that they had to make this move to bring lean into construction and do things differently. Set up the IGLC, set up the LCI, and then very heavily influenced here in the UK, Rethinking Construction Report, which is a kind of seminal report here in the UK for us into how things were doing differently. And that was embedded by John Egan, who then was the chairman of BAA, into how we're going to do things differently in building airports in the UK, which is where I kind of picked up in T5 and slightly before. So Egan was driving this very hard in that environment to bring it into construction. How can we bring this stuff into construction and do things differently? I know in the States you had similar flagship projects, and then really since 2010 and beyond, it's become more kind of mainstream in how things are done lean-wise. Is that kind of okay? It's a bit of a background of what lean is and how it's got to where it's got to. I guess we're a little late already, so you've got even less time. Right.
On left-handed side, left-handed side. So DfMA, design for manufacturing assembly. I tend to like diagrams as well, so I've got some diagrams, but its ultimate goal is to have the ability to pre-combine a large number of components into modules, and those modules to be assembled off-site and then, or not on the field, and then brought into the construction site and incorporated through a small and simple series of tasks. I fully understand that in industrial construction, modularisation is a big piece, but I want to explain, perhaps a bit later in the case study, how DfMA can take that further. So this is just a diagram representing that, and on my case study later, I'll show that on a sister project, I followed the materials on the site through laydown yards, through manufacturing facilities, and how work was performed at the workplace with literally thousands and thousands of parts and how that affected the outcome of the project. So really, it's about the ability to, if these are component flows, to have these flow into manufacturing units and have modules flow into the construction site with all of its adjacent components or associated components through this simple, they can be large, but a series of assembly tasks. So Nigel mentioned that it's not one size fits all. So if you have a component set, and I'll show the next slide what that means, then if you're building a hospital, for instance, then you can configure a unique hospital around standard component sets. And component sets for the product families, the MEP product families, or structural components, precast units, stairs, shafts, etc. So it doesn't necessarily mean you're fixed into a particular design. And obviously the essence of this is to design in this way, because if you are manufacturing modules, then they need to be designed in a certain way that they're transportable and installable. Okay, so everyone read that? I'm not going to read it back. So generic MEP product families, so MEPs and mechanical electrical public systems. So I am a newbie to AWP, so majority of my later sort of working time has been building hospitals. So if you take MEP systems from the fat end of the system to the thin end of the system, and by that I mean plant runners down to points of use, taps or electrical sockets, etc. They divide into natural products. So you've got volumetric modules, that can be whole plant rooms, it can be bathroom pods, it can be whole operating theatres, for instance. Equipment modules, so if you've got embedded plant rooms inside concrete structures, so those are plant skids, etc., etc. Glorified skids. You've then got vertical and horizontal distribution through the facility, all above the ceilings and in shafts. Terminal distribution modules, so in a data centre that could be crack units with all its associated equipment around it. Electrical modular systems, modular wiring, for instance. Building technology systems, incorporating all of the low voltage systems into one network. And then kit parts. When all those are assembled in a particular sequence, they form complete MEP systems. You can also substitute that for concrete components, for other building fabric components, cladding systems, that sort of thing. So it's not restricted just to MEP. So from a design perspective, these are just generic design stages: concept, develop design, technical design, pre-assembly, on-site assembly, test and commission. So this is the design funnel, so this is where you're iterating at the start of the project, and these different lines mean you've got a wider iteration if you don't have component sets or strategic solutions, so you've got narrower choices because you're designing around component sets. Keep the same components, product families, as many terms for them. So you put into the start of this what the customer requirements are, the business core values, the overarching aim and objectives, might be to say 30% of time, might be to drive 60% labour off-site. DfMA guiding principles, how designers and architects are expected to perform around components. Design parameters, literally how things fit together, what adjustability and tolerancing you should allow for. Ground rules, creating a common understanding, that's bringing the team up to speed, the objectives of this process. Understanding the engineering principles of the product family, design guidance, I'll talk about ABC parts analysis later, and then understanding the benefits. Because in general construction, DfMA can be seen as a cost because you're putting things into frames, so you need to understand the cost benefit of that. And basically this funnel means that at the concept stage, you need to start applying the product family, apply the ground rules, do your design iterations here, because as you get more towards detailing for manufacture, then you want the design frozen. So submission should be made at this point. You've agreed the concept designs, you've locked it all down into manufacturing. That might be it. Case studies. Is that okay? Understand?
Yeah, we'll have opportunity for questions. Okay, so let's just talk about some basic case studies, not to go through them in depth because they deserve that, but at least look at some cases that are really meaningful to each of these concepts of advanced packaging. So the first one I want to talk a little bit about is AWP, of course, and one of the great examples is really around what Dow started maybe 5 years ago as a classic case study of an organization just completely enveloping all the aspects of it and readying their organization internally before they before they launch on their job. So, they have the goal of reducing total install cost by 30% enterprise-wise, change the ingrained culture, and I told you that culture is the biggest thing, and they spend a lot of time getting everybody on board. And then they engage their supply chain. That was one of the key aspects of it. So they did have a lot of consulting going on. They brought out some new technology specifically for advanced work packaging to blend in with their current technologies, right? It's not like I'm just completely swapping out something. They developed the AWP toolkit, the interactive playbook, so that was pretty exciting to work with them on that. So what they did, they got some really proven results, and you can look at structural steel productivity increased by 92%. Who would have thought structural steel? Piping productivity by 68%, double the industry standard for time on tools. Won the Dow Chairman's Award and on their first job. So it was pretty stellar. But all the prep, and not everybody does that, right? Spends a year or two readying the entire organization before they launch. A lot of folks say, I need to go do it, but I also want to start applying it right away. So there's different approaches. So what they did is, and this is their timeline, hey, they jumped into it in 2015 and then started their journey, and finally in 2020 started really applying it onto the project. So there is a journey for sure. They mapped over their systems, their current systems and process and procedures with AWP procedures. So they understood where the handoffs are, right, and what the roles and responsibilities of each of their functional groups were going to be. Then, I talked about the technology. They started understanding what they had and where they had. In this case, they adopted Construxam and the Bentley system for that, and we were part of that evaluation. And now they're in another process of reevaluating all that and coming up with new systems. So again, it's not fixed because it never is. And then they realized that data is key here, and data and part of the digital threads I mentioned earlier. They embraced that and started connecting all the dots within their own organization. All right, so they embraced the whole data side of advanced work packaging. And then again, here it is. At the end of the day, they announced here's the opportunities, here's the things that they went and did. Right. So that's the whole purpose of advanced work packaging. So advanced work packaging and what you heard Bill O'Brien say this morning, that study and that maturity curve, it was, if you go do this, you will get benefit. It's causational, right? It's not where you do this and do this and do this. But now in this case, we get those benefits. Now their goal, of course, was to really advance beyond that. So how do we advance beyond that? We start looking outside of what we currently think of advanced work packaging and start bringing in AWP, Lean, and DfMA, right? So another exciting one, and they're here in force with Eastman. But I see this as a classic because they took it to a scalable level, right? They were a facility and they needed to look at a different approach to advanced work packaging that suits them, right? So, their project and budgets and timelines were bloated, there was no effective integration going on, and the construction teams were actually work as drawings were produced. That was one of the first things we saw is that, hey, here's the drawing, let me get that, I'll go out and work in the field. Of course, one of the first things we said was, hey, stop doing that. That's crazy. Why don't you at least give us 2 weeks to kind of sort out the constraint problems? And so they really took to AWP. They created fit-for-purpose portfolio solutions, implemented best practices, and leveraged work packs and other 3D next-generation IDPs and using 3D, 2D data. So they're also look the results they got: 53% savings in labor to each dollar spent on materials was pretty phenomenal. I think they're even better than that now. Got some Eastman folks in here. Reported significant productivity improvements, opportunity identified with business value analysis, how they got there, and then increased visibility and predictability in their program. So this was another great case study on a scalable type project. So let's go to Nigel.
That's me. I've been here for 20 years, don't worry.
Yeah, I know.
So, I'm going to whiz you through in 5 minutes, just quickly whiz you through a case study. So I worked with this organisation from about 2007 to about 2016. Anglia Water is one of the big UK water suppliers here in the UK and East Anglia. I think they say that East Anglia is drier than Jerusalem, bizarrely. So that they've a real interest in water conservation. And they actually spend about £600 million in an alliance format over a 5-year period, an AMP period they call it. Okay, so this is where I have to come clean and say, I really like Jay's presentation this morning where he talked about stealing. I just steal. I'm a lean practitioner, but actually I'll use anything if I think it works and I think it melds well. And I think where we come from in our world is that we're really keen to understand what the client's understanding, vision, business objectives are, and then we'll help them figure out what the right environment is to create that and allow that to happen. I'm going to talk a little bit about that in the case study in a minute. Then the tool sets really become somewhat incidental. We can create the right environment, the tools kind of make themselves obvious as to what we need to go use. Ooh. Wasn't expecting that either. In terms of creating, done some really crazy things on this right transition. In terms of creating the right environment, which I was talking about a minute ago, so what Anglia did, which was very smart, they aligned their own organisational goals and drilled them down to make them line up with what they wanted their construction and delivery teams to do. Okay? That took them a while, and then what they did is they got the commercial model line, and again Jay was talking about that last session before we broke up about the whole lump sum versus collaborative framework. They actually incentivized their 6 key partners into delivering things in a way that they wanted, but would also incentivize the partners to do better. So they put profit at risk, cut into it. That's what they did. And what that did, that created a whole different team dynamic. Going to Fernando's culture, it meant that all those teams, 6 different organizations, some of which are here actually today, 6 different organizations, excuse me, actually pulling for each other, and when one organisation got into trouble on a project or a program, the other organisations would jump in and help. So that's kind of, it took a while to set it up, but that's kind of one of the biggest things you can do to create the right environment. And then what we did is work in that framework to provide some really quite stretching goals. I'm not going to go through them all, you can read them for yourselves, on what they call a pathfinder scheme. So every 5 years they run several pathfinders across the different packages of work that they run to set the tone for how they want to do things differently in the next 5 years. So we help them set up to do things differently on this particular project. And this was all about time on site really going down, because they recognised if they reduced time on site, they could improve safety. They recognised if they reduced time on site, they could almost certainly reduce costs. The preliminary costs are so high. And also that they took a bet that they reckoned if they could reduce time on site and go off site, they could reduce carbon. And what they found was it was almost a 1-to-1 benefit in terms of the amount of time you save and the amount of carbon you reduce. And then the other thing they did in creating the right environment is they engaged the tier 2s. So they went down in the supply chain to the guys at tier 2 level and really started to get them involved and mirrored up the commercial arrangements with them and actually got these guys to the table. So these guys have the inherent trade knowledge, so they got them to the table and got them involved early and started to have really strategic business-to-business discussions with them, and we went and did a whole lot of value stream mapping work with them as well, so to understand upstream what the constraints and the problems would be to delivering downstream. And then what the team did is they developed this integrator approach. So this is taking your typical tier 1 or GC, maybe in your language, taking your typical GC and actually turning him from less of a controller to more of an enabler. So actually making that guy really drive the integration and enable the rest of the team to deliver rather than control. So the contracts with the tier 2s were placed direct back up to Anglia, which meant that actually there was a more facilitative and collaborative environment to go away and do things. Then we did some lean stuff. kind of incidental after all that. We did some lean stuff. We did a whole bunch of souped up glass plan stuff. We did a whole bunch of listening to the guys talking about the 4D stuff, a massive amount of 4D visualization, 4D planning, and then we did a whole bunch of productivity improvement stuff too. So physically going out in the field, we call it activity sampling, measuring what's going on, mapping processes, figuring out how we can improve, crew balancing, all that kind of stuff to make things go better. We also did some DfMA. So again, going back to that previous slide where taking time off site, we really looked at the whole feasibility of how you build, in this case, a sewage works with our friends from Bryden Wood, and we chunked it down into work packs. Unbeknown to us, we were actually doing AWP, but in a kind of, I call it caveman AWP, because it doesn't want terminology. But that's kind of how this stuff all starts to read across and come together. Yeah, I talked a bit about 4D models and BIM and the whole rest of the stuff. We also did some first run studies. We actually went out and made some stuff before we even got anywhere near site. We were worried about a couple of particular bit of risk areas, so went out and built it, tried it, learned a bunch of stuff and fed it back into the main design. And then we also got operations, again, listening to, I think it was Graham talking this morning, about the operations stakeholders in the business. So we were able to get operations involved before we built anything and get them inside the model, looking at the model, actually figuring out what the right O&M access points and methodologies would be. We actually changed the design because of that before we get anywhere near going on site. So that was great. And that was us.
Back.
Seamless handoff.
Hello again. So this is a case study, Northern Water Treatment Plant in rural Queensland. So prior to this, we built Kenya Water Treatment Plant, and it was a sister plant. Mainly the process was the same, slight different configuration. 100 megalitres a day capacity. Our target was to build it to get to mechanical completion in 63 weeks. Obviously, remote location, extreme weather and difficult logistics. Living in a camp, rostered work periods, it was fly in, fly out, which was about the sister project. It's a critical schedule to meet gas production target dates. You can't produce gas without treating the water. As a byproduct of fracking. And we had to hit or beat time cost versus the stick twin. Sorry, I'll just show some pictures. So these are some images of two different images, various start processes up to the brine concentrators and then the treated water ponds. So we had to build 5 enormous ponds as well. And there was remote outlying pumping stations. That's the glorified pond and the raw water ponds up here. Talked about that. So I'm going to touch on the results and then just explain how we got there. So we did go faster. We delivered the facility in some mechanical completion in 63 weeks, which was 30% quicker than its sister plant. We beat the budget by 20%. We reduced skilled and de-skilled labour by circa 60%. Pre-assembly was over 70%. And the project was awarded that water project at the year 2016. What I will say is that at the start, the design was probably 70% complete when we decided to incorporate DfMA into this project. And my role was to flip this to a DfMA project. So we made rules and we stuck to them. So the rules were, we're going to pre-assemble 70% off-site, we're going to remove 60% labour off-site, and we're going to reduce the program by the schedule by 30%. And one of the main rules was we're going to DfMA everything unless it's not possible to DfMA or it's not feasible to DfMA, to modularise it, such as large underground piping, large above ground piping that were just too big to modularise, and that on their own, so you wouldn't put that in a frame, for instance. So we developed a complete modular strategy, and that's just walking through the model. Based on the technical complexity of the plant itself, we developed a path of construction. And obviously the most complex parts of the plant, which is the reverse osmosis main process plant, would take longer. So that's how we decided the path of construction with the outlying pumping stations being the last things to start, but also the first thing we needed because we had to start commissioning those in terms of the process flow. That's Nigel's term, it's a caveman approach, so we did last planner daily production planning, we did that in the fabrication facility which was in Newcastle in New South Wales. So one fed the other. We align the mechanical and electrical completion through this constructions, plant commissioning sequence of durations. And the engineering, procurement, and manufacturing work packages were all aligned with budget into that, so that path of construction. And we built a crew balance tact production system to make workflow at an even balanced tact time. Tact time is, if you're in a factory with a pulse of the production system itself based on customer demand. So let me just say, if you're in a car factory and you've got a cell that assembles parts on a car, that might take 30 seconds. The next cell, which adds the next part to the car, also needs to take 30 seconds. So if that was a minute, then you're imbalanced, and the previous cell, the product would have to wait. It's about balancing all of the work activities. So we meticulously thought that out with operatives, so with riggers, with pipe fitters, with electricians. And then we developed the tact sequence. So bases were placed, modules were assembled in sequence, so the base just added the module assembly sequence through the path of construction. Process kit was assembled in sequence, then the kit of parts associated with them, then the next module group commenced. Everything was delivered to point of use, so there was no lay-down yard. And the sister project, which was stick built, was a huge lay-down yard with thousands and thousands and thousands of components put out there and then brought quite a long way to point of use. So we overcame that by just having containerised kits of parts. So these gasket walls inside a container placed at point of use. We had a field office at every point of use. And then bulk containers at point of use. And we learned that some of the bolts, which are quite large, when you get them to the point of use and you try and run the nut of the bolt, doesn't fit. So we did all that here, so we're not doing it in the workplace. And then bolt trolleys, so you're not carrying armfuls of quite heavy equipment. So the production system, just to talk about this, we divided all the parts into ABC, which is a manufacturing categorisation of parts based on Pareto. So the fewest, most expensive, and the highest amount at the least cost. So these modules go straight to the point of use, and then B and C parts kitted, also delivered straight to the point of use. In a lean system, moving to people is a waste, so we want the operatives just to assemble. And then this represents the sequence, so you get team 1, week 1, in zone 1, doing their work, fed by all of the components. And this postponement function means that parts are delayed until the moment they're needed, but configured to exactly what they need. And then week 2, team 2 comes in, and as team 1 has moved on. So site operations with final assembly of modules and components of complete systems, it's pulse-driven tact time. And we spent a lot of effort looking at ergonomics, worker ergonomics. So the amount of physical effort was reduced as much as possible. Even if electricians were wiring up control panels at low level, instead of sitting on a bucket, we provide them with mechanics benches on wheels, so they put all the stuff below and just zoom around and do the work quite well. Logistics. So we didn't start off, we did May in mind, so we did have a lot of GE. GE was a water technology supplier already on site at one go. So we set up our assembly facility with an assembly lane yard right next to it. All of the components which came from overseas, from Australia itself, into the laydown yard, assembled them into steel frames that were galvanised, and then assembled modules and kits of parts to site, and that's the results. So, Northern Water Treatment Plant, 84% of large bore piping was incorporated into modules. The SUF tanks, which are structural concrete tanks, made components. 90% were built off site, and the chlorified water tanks, 86%. Assembling the modules, we had 70% less labour. The SUF tank 60, the clarifier 60% less, and we reached mechanical completion in 63 weeks. Came from Wall Street, it was 100 weeks with much less people, and we reduced the cost by 20%. That's it.
Thank you. All right, so hopefully you're starting to see how all this can actually contribute to net zero as well, and how they all blend together and how they all have common objectives. So again, we're looking at AWP plus Lean to deliver a lot of key results. You know, so I think at this point, I do want to put a shameless plug. We do have an AWP plus Lean joint working group, which we are all members of, that are looking at these types of solutions. So if you're interested in joining that, you know, please let us know. You know, we're coming out with reports of comparing AWP plus Lean, you know, and their similarities and where we can drive benefits. We're working with CII and LCI, Lean Construction, and publishing reports. You know, and they're small, you know, 2-3 page reports because that is kind of about as much as we really want to read. So one on what is it they're better together, and another one which is addressing the cultural, you know, what does organizational culture really mean for advanced work packaging. All right, and I think with that, I want to thank you all. I think we may have a little bit of time, around a little more than we thought, but we really appreciate you attending this. And if does anybody have any questions, we'll hang around and we'll answer them. But I know I'm between you and lunch, so a very dangerous position. But we will certainly answer questions if you have them.
Well,
Yes.
I have a question. Quite a few times you said it took a while to set it up. How long's a while?
So I got engaged in 2007. They've been running the framework since 2005, and they got, I think it was the third cycle they actually got the commercial arrangement in place, and that was a game changer.
Yeah, so that's 5 years.
Yeah, so year, I think it was either year 6 or year 11. I think it was year 11 probably.
It does take years.
Now, to be fair, they were coming out of being, you know, nationalised industries into privatised industries, so there was a bit of a journey
Yeah.
anyway. But getting those commercial arrangements in place, they're a lot more commonplace now. They were the first in the industry, in the infrastructure industry. And, you know, I won't mention the tier ones, but they're some of the biggest tier ones in Europe. The conversation about going into a putting profit at risk relationship went right to the very top of the
Yes.
main board.
Yeah, yeah.
That's how it had to be shepherded through discussion-wise, governance-wise, big decisions.
But it was good to hear that an infrastructure project. I'm in the infrastructure sector.
Okay.
And I think nearly everyone else in the room
Yes.
is not. So,
All right, okay.
Yeah, so it's a good question because all these are long-term journeys. Projects are continually going, but what do we feed into the project? But at the Dow case study, for instance, you know, they've been on. They still consider themselves to be on a journey, and it took them at least 3 years to really set it up the way they wanted to get it set up before they launched it. Yes, sir.
Just on that then, so whereabouts in the project life cycle did you get involved? And we were talking about before final investment decision and the execution really starts, or are you getting involved, you know, well speaking, that detailed design is happening?
I'll answer in 2 ways, give you some thinking time. My most successful interventions have been really late in the cycle, when things are going wrong on site. Normally, if I'm talking to a potential client and we're thinking about how we get involved, I say, look, is there something that's keeping you awake at night right now? Yeah, that project over there, okay, let me go there. Because you can make a difference on stuff that's going wrong. The best time to get involved, obviously, is at the front end, because you get a chance to set things up.
So the examples you provided, there was more coming in, we recognise that there's a problem during our execution, we have to fix it.
Yeah.
So
So last panel, whether you know, the last panel was originally developed to finish snagging on a large hospital. They couldn't get the snagging finished, so they just implemented last panel and all of a sudden brought some structure to it. Rework.
Oh.
And at the end of the job, the last bit, sorry, it's the phrase.
My experience on
Same language, different language.
on healthcare and mainly PFI or PPP is that if you implement this right at the start when you're tendering the project, it just comes through because you influence remember the funnel? Influencing the design team, because we want to configure distribution systems a certain way, as opposed to trying to squeeze everything in corridors. So we do it a certain way so we can get standardised solutions. You can modularize. You wouldn't modularize ducting, for instance, in ours because it's big in its own right.
But it's a really important thing there that you need to figure out what you do with that risk though. So I've seen that happen where they've gone through the whole early design process, make it modular, and then they try and dump the risk with the contractors, and they go back to business as usual because they're too scared of the risk of doing it that way.
You can also take the view that if you've got distribution systems in a hospital, obviously they're the largest diameter, let's say, cable pipes closest to the riser, and then they're the smallest at the end of the system, serving the last room. So why would you modularize that? Because you've got these modules with just a few things in them, but you have to take it as a whole, because you wouldn't just fit out with modules most of it and then field run all the last bits, because it just doesn't work that way. So you have to take the whole value concept into place. On Northern Water Treatment, the design was 70% complete, so it wasn't too late to do it, but it meant reconfiguring spool drawings, steelwork drawings, etc., etc. So there was a cost for that, but the benefits way outweighed that, if you know what I mean.
And the challenge we're dealing with at the moment, if you go modular, you're off-site somewhere, the risk of the transportation from wherever you've made it to the site, who is responsible for that? And that's a big sticking point right now, because it's a tier 2 or 3 even have provided something, and in theory, it's their responsibility all the way up until installation.
I would say that too. I would agree with that.
But that's where there's a lot.
If someone else is providing the transport, then that's a question, isn't it? But you should package
But that's where we're
transport
stuck. I'm saying
into
that's
the.
where we're stuck a lot of the time now.
I'd probably answer that a different way to Peter, in that I'd say at the end of the day, the client probably takes the risk for everything anyway. So maybe the client has to step into the breach there and go,
Yeah.
okay, what do we need to do to unlock this? I'll take the risk.
That's-
Yeah. Right,
Yeah.
and that's that production system to look at. How do we combine this, and who is going to be responsible for it? Because ultimately, I agree with Nigel, as the owner has risk for everything, and they need to manage that risk. And sometimes it's not just, hey, that's the contractor, and we just got to step away as soon as we give them something. You know, you can still drive requirements, but it's how do I integrate our work efforts together to optimize the end results? And that is a tough part for most organizations to start adopting, because of that risk question or the means and methods. Oh my gosh, we could expose ourselves. You know what? You're exposing yourselves all the time. And the fact that you go that route, you're going to end up with claims and all sorts of things because there's battles, and I got to go up to this communication route to get down to this one, where there's just better ways of doing things. Right? And that's at least that's our collective interest on this side. Yeah. So, any other questions? I know it's lunchtime. I can probably hear all the stomachs gurgling out there, but I'll take one more, or if you want to go ahead and just grab lunch, we'll be here for a few minutes, and we'll stay for some questions. How's that? All right. Thank you very much.
Thank you.